So
So,
I'm Pietro Bartoccioni. I'm working for Aruba, one of the company that are part of the Sovereign X consortium. We are, let's say, working. I'm the lead of the IAA team. The IAA team is the team working regarding the component for Simpl-Open that deals with identity, authentication, authorization. And I also launch my presentation, hopefully sharing it. So we are, let's say, and I'm also have a double role in this event. I'm also the lead of ICAM, of the Identity Credential Access Management Working Group. And let's say in this presentation, I would like to highlight the fact that we will bring the ICAM semantic model that is, of course, related to identity access management and so authentication authorization to the Simpl-Open implementation. And now I'm trying to, let's say, share the presentation so that I don't know if you can see my screen. Hopefully, yes. Um, Tell me whether the
yes, I
screen
can
is.
see your screen.
Okay, so basically, as I said, I'm about to present how the sensor identity tier 2 implementation would be adopting the ICAM semantic model, so putting the semantic ICAM model in action onto the European Commission founded Simpl-Open project. An introduction of what is Simpl-Open is the open source smart middleware that enable cloud-to-edge federations and all the major data initiatives founded by European Commission. Is composed by three products. Of course, Simpl-Open is the middleware itself, and then there is Simple Labs, is a playground on which the middleware can be tested, and also interoperability can be checked with the existing data space, so you can put in place Simpl-Open with your own data space needs and also check how to integrate your own services inside Simpl-Open. And the last, it's Simple Life, is a set of, I guess, seven real data space, existing data spaces that are driving the adoption of Simpl-Open to, let's say, brownfield brought inside the Simpl-Open implementation. First of all, I would like to introduce what is very important in Simpl-Open, the introduction of a two-tier architecture, IAA architecture. That means that the participants are, let's say, need to install an agent and they can, let's say, integrate their own local ADP to the agent so that then the end user acting for the participant organization access the data space through the agent. So basically, there's no in Simpl-Open interaction between, for instance, end user of a participant to another agent's services directly, but also but only with machine to machine. And the authentication, the identification, authentication, authorization of machine to machine communication is the key part. As we can see, this what you see here is extracted from the tender document architecture vision. So represent the requirements we received, and of course, note that when you see end user here means consumer. Because initially in the Simpl-Open, the consumer was identified as an end user because I don't really know why, but they used to call it that way. Then, just to make it clear, this approach enable having the end user, so the person, as to be treated as first citizen class. In fact, I presented last year in the Gaia-X architecture meeting, and you can find the record of this, and I will not, let's say, deep dive on this diagram. I presented how simple open agents and the two-tier approach. So the tier one, that is where the end user connect to the agent, is integrated with the EIDAS framework and using the building blocks of European Commission. So I'm talking about EID and the e-signature that are integrated. For instance, EID is integrated already in the middleware delivered. So there is an EIDAS node that is working properly, and user that has their own state credential, EIDAS credential, can log in an agent that is configured to use the EIDAS node through the EID building block. The e-signature is integrated by the team, the contract team that is working on letting the signature, even the contract negotiation signature, done through qualified signature, and who deal with the IDAS framework knows exactly what does it mean. So coming back to the tier two, that is what is where the semantic model come in place, where the interoperable ICAM semantic model come in place. I start from what we received as a requirement. We were asked to provide three options for the machine-to-machine communication. All of about option that also relies on MTLS to ensure that all communication are from and to a trusted and active simple open data space participant agent, and across. And this is also working on federated data space, because in simple open for IAA, the functionality like searching, catalogs, and consuming, we already are implementing, and we are in the middle of implementation, the federation. So two simple open data space that adopt the IAA building block and the onboarding can federate each other. And the model of federation, even if actually is based on X509 and identity attributes, the two first options that were, let's say, requested, are then evolving with the third option that is exactly what bring us to implement the tier two self-sovereign identity option using the semantic model. So just a note, even if the architecture vision document was not explicitly mentioned, the IDSA RAM, we stick to the fact that option one and option two are implementation of identity for devices, but we removed the tracking part from the dynamic attribute token. So to let, let's say, anonymity, so to avoid tracking, we slightly modify the dynamic attribute token, but for the because the ephemeral proof, that is the alter ego of the dynamic attribute token, doesn't have the target of the communication. So an ephemeral proof can be used to communicate with any other participant in the data space and across federated without being tracked by the issuance. And this is an important topic. The option three will be, as I said, an implementation of identity for participant that the IDSA RAM defined as a baseline of any other, let's say, implementation, protocol implementation, like the DCP, like OpenID Connect for VC, all the other verifiable SSI based and verifiable credential based identification, authentication, authorization implementation relies on, are identified by the identity for participant in the IDSA. So in the data space protocol definition. Going on, I also put here the requested implementation from the tender of the option 1 and 2 compared from the IDS RAM, identities for devices, as you can see, is exactly the same. But as I said, I removed the target from the dynamic attribute to avoid the tracking part. And so it's let's say sensor identity or anonymous or privacy preserving implementation of this IDSA. Uh, Going on, just to make, and I don't want you to deep dive on this diagram, just to make you aware that the optimization on performance and what is the sequence of what is implemented in the exchange of any communication. I just want to highlight the fact that the key pair, so the private key, it's always installed, generated inside an agent. So then the certificates and the ephemeral proof are bound to this, let's say, credential, X519 credential, but still then fully autonomous because the only part on which any participant rely on onto the using even the X509, let's say, version, it's to check whether the certificate issued by the identity provider still valid through OCSP. Then any single action request, it's done using MTLS. So zero trust architecture, zero trust network. There's no possibility or chance to do man in the middle, impersonation attack, spoofing attack, that other, for instance, other implementation can be, let's say, possible or theoretically possible to be done. Just to make it clear, the option request, and I'm coming back, when you see this graphic, it's always coming from the requirement received. We had received the same, let's say, approach using SSI. I would like to highlight the fact that this schema and this requirement pops up into 2022. So before some other, let's say, specifications, the semantic model itself, the ICAM semantic model itself, were adopted or spread or becoming more standard. But indeed, you can see, and this is a public document, you can even look up how the communication using SSI option was relying on. And I want to highlight that even using the SSI implementation, the mutual TLS authentication is always foreseen as a demonstration of the of proof of possession of the key bound to the verifiable credential itself. So it's exactly like in the other two more spread protocol, but every single action it's let's say authenticated, and there's no accession token who bring the possibility of let's say various attack. Going further, I also, let's say, show how the requirement foreseen the data space federation. I will not, let's say, express or deep dive on the specification. Of course, it's in the architecture vision. It's available to be done, read. And here is what we are about to do in the implementation. Simpl-Open will adopt the ICAM semantic model that is designed with interoperability agnostic in an agnostic way in mind, to be agnostic in mind, in order to enable the IDSRAM identity for participants. So to have credential that then can be used not only on the implementation that we will put in place, but potentially in the future also for different credential exchange protocol. Basically, this would enable what is a simple open data space even to be integrated with non-simple open data space for federation and for, let's say, communication between participants. Using the Gaia-X semantic model to enable SSI. So Simpl-Open will use a specialization of the party credential, and here I need you to have a more clue of how the party credential and the trust anchor credential and the for the federation the trust relation credential works. But in any case, we will be using the party credential to implement the simple participant credential that will be issued by the Dataspace Governance Authority to all participants. And the main user property of this credential would be the identity attributes which contain all the identity attributes assigned to the participant and using in attribute-based access control during the agent-to-agent communication after the MTLS, of course. The holder, which identify verification method bound to the public key of the current agent-controlled key pair, also used in MTLS. You see, this kind of strong binding of public key pair in a credential, because we really need to adopt a strong binding like the European Digital Wallet Architecture Reference did with the PID that also, let's say, embed in the credential the hash or the public key of the device. So we do the same in the party credential, and we use the holder public key verification method in order to check also MTLS connection. So in a decentralized way, MTLS can be done without any problem. So even let's say extending the concept, but the MTLS must be always in place because the main purpose, the main target of Simpl-Open implementation of the middleware is to keep the security at max in every situation. And the agent and the implementation of the tier 2, it's looking always and keeping always this requirement on top of the list. So you can see also another property that is, as I said, the strong bind, the public key digest will be included using the subresource integrity. It's what is used also inside a verifiable credential data model to references external resources. And we use it for the public key retrieved with the holder property. So these two properties work together and are used, as I said before, to demonstrate, to strongly bind a credential to the public key of the holder and check the proof of possession during presentation. In fact, let's say process you seen before will be translated with a simple verifiable presentation to exchange after the MTLS the presentation of the credential and to ensure through the MTLS combined with the presentation that the call is coming from a trusted and the private key holder properly. So then also we rely on the credential status using the big string status list, so the privacy preserved control over the issued credential, and we will be so completely decentralized and SSI compliant. Then we will use the semantic model also to enable dataspace federation. And of course, I'm again pointing out how the trust scope credential is used and is foreseen to be used in the ICAM semantic model to enable interoperable federation across dataspace. So basically, Simpl-Open will use a trust scope credential to implement specialization, to implement a simple dataspace credential. And this credential is self-issued by all dataspace governance authority and can be used by other dataspace governance authority that wants to establish a trust relation. As described in the ICAM document, here it is the section, the trust relation is monodirectional and bidirectional or full, or a federation can be achieved by combining two opposite trust relations. So is always the atomic part is always monodirectional. Combining two monodirectional become a full bidirectional federation can be achieved. I just want to open a point. Trusting another dataspace governance authority trust scope credential means that the trustor need to know the semantic model, at least the IAA semantic model of the trusted data space, in order then to map the claims or the identity attribute. We are using identity attribute, and it's slightly simple to be managed and to be, let's say, defined across data spaces. So the trustor need to know the semantic behind the identity attribute of the trusted, so that then a mapping in the issuance of a trust relation credential can be let's say, established and fine-grained. And it's the way the trustor will identify and remap certain identity attribute of participants that are coming from a data space to their identity attributes, and so and this allow the trustor to define an additional identity attributes to treat the federated participants in a different way. Then what become possible next? And this is the last, let's say, content slide. And I know probably I'm.
We really need, Pietro, we really need to come to an end. I have granted
you.
Yeah,
this is the end.
Okay, perfect.
Yes, sorry. And I try to be as fast as possible, and I hope I was able to be understood. So this is what the implementation will implement, and what will be possible in the future with the implementation of SSI. So integration and embedding Simpl-Open of other SSI-based solutions, like the decentralized claim protocol, using the Identity Hub, implementing these three resource store could be possible. So an Identity Hub could be embedded, and the decentralized claim protocol can be embedded inside the secured mesh that Simpl-Open already put in place. Same stuff for identity, for OpenID Connect for verifiable credential could be implemented and embedded. And also, last, as I already said, the federation with not Simpl-Open data space adopting the ICAM semantic model could be possible. And of course, extending the existing zero trust MTLS agent communication to external participants. And that's all. I guess we are at the end of this very full of content presentation.
Yeah, thanks a lot, Pietro, for that deep dive and broad ride, actually, or gallop through the different options. Thanks a lot. We are